Guys, we are graphing sine and cosine. And what you are going to see right here are the basic graphs of sine and cosine. You're going to need to have those memorized, essentially. Okay. The more we work with them, the more they will sink into you. If you took your calculator and you graphed sine and cosine right now, assuming you're in which mode? Radian mode. Okay. Sine and cosine graphs would not work in any other mode. They have to be in radian mode. But assuming you're in radian mode, if you recall from what we did when we back in, lesson 1.3, where we had all the graphs, sine and cosine were up, down, up, down, up, down, up, down, up, down, right? So the piece of graph you're looking at right here is just what we call one cycle. The cycle that we're going to want to use, or period, either one. One cycle or one period of the graph. Okay, so a sine graph. This is one cycle of it, one period of it. The basic period, it starts at 0, 0. And you'll notice it goes from 0 to 2 pi. So once around the unit circle, right? That is one cycle, or one period is 2 pi. You'll notice it goes up. It has a max above pi over 2. Crosses back through at pi. Has a minimum below 3 pi over 2. And then crosses back through at 2 pi. Okay, notice it goes as high as 1, as low as -1. Yeah. Now, cosine. Do you guys remember looking at sine and cosine graphs on the calculator? They both went up and down, right? And they were all very much the same, other than one was shifted sideways from the other, right? So this is just a different piece of the graph. Okay, so cosine, when we look at one cycle, or one period that goes from 0 to 2 pi, it's just a different segment. Basically, this would be on sine, if I started here at pi over 2, and then I ended up here at 5 pi over 2, that's the cosine piece. So it's just a different shifting of it. Okay, so cosine starts at a max at 1, has a 0 or cuts through pi over 2, a minimum below pi, cuts through or has a 0 at 3 pi over 2, and then max above 2 pi. So one thing you need to know, the shapes of the graphs, right? So when I say sine curve, realize, okay, one cycle is you're going up to your hill, then down to your valley. Whereas cosine is just a big valley, okay? Or whatever terminology we want to use. Now, if you've looked at the ones we're going to graph, and I don't even know if we'll graph all 6 of these in the notes, because they take a little bit to, dissect, but your equations look like what you see right over here. They're in that form. And there's a lot of numbers with them, isn't there? So those are both in the same form. It's a times sine of bx minus c plus d. And cosine is a similar form. A, b, c, and d each have a different representation. Okay? A, officially, now notice it says the absolute value of A. So the positive value of A is defined as the amplitude. It's how far above and below the center line to count. Well, the normal amplitude, how far above and below, how far up and down do these graphs go? 1 and -1. The amplitude might take that and change it. Think about transformations. What is A in the position of? What would we compare that to that we've done in the past?
A stretch.
A stretch or compression, right? That's what A is. It is your stretch or compression. Now, the trig function, we call it amplitude. But it's essentially the stretch or compression. Okay? 2 pi divided by b. So notice b is your coefficient of x. I really thought you were just going to leave him hanging.
I thought he was for a second.
I was about ready to walk over there and take care of it. So I was like, man. Okay. I know he wasn't looking for, me, but can't leave Connor hanging. Okay. B. The value in front of x. If there is a value in front of x, right? Won't always be that. But 2 pi divided by b tells you the length of one cycle of sine or cosine. So length is usually 2 pi. It could be longer or shorter, depending on that b value. And so that is, we haven't done a whole lot with that, but that, instead of being vertical, that is your horizontal stretch or compression. C over B is your phase shift. So C divided by B, that is your phase shift. This tells you how much your graph moves left or right. And if you look, that plus or minus C, that's a number added or subtracted in the parentheses, yes? That would normally be a horizontal shift, and so that's what that is telling me. And then D, what we call this is, we say it's our center line, but notice this plus D is outside at the end being added, right? It's really how far up and down your graph translates, right? Now, with that in mind, it's a lot more difficult to have to draw this graph if we are going to move it down or move it up. So what we're going to do is, instead of always calling the center axis 0, calling our center line 0, we'll just rename this. That way our graph is always centered on this line. It makes it a little easier to graph. And then, of course, a negative A value out front just says that our graph is going to reflect. Okay, and that'll just reflect upside down. Okay, I just looked in my notes. And in the past, all that extra information I was telling you guys, I've written out here on the side. Is it worth it?
Yes. The only thing I put was the stretcher compression.
Yeah, it just, yeah.
Just
So
remember that one.
amplitude is your, I'm going to say vertical stretch. Do we use the word compression as opposed to shrink in here?
We used
Yeah.
shrink last year.
We've used both,
We
so,
use compression earlier this year.
okay. I
I
can
like
never,
compression better.
okay.
I like shrink. Okay,
Of course.
well, put them on shrink.
Well, here's what I'm going to say. You write whichever makes you happier. You can write compression, you can write shrink. I just wrote compression on the board, but as I look at my notes, I have shrink. Obviously, it depends for me from year to year, so.
I wrote comp because I ran out of space.
I almost wrote that. Okay, 2 pi over b, that was the length of one cycle. That is your horizontal stretch or shrink, or your horizontal stretch or compression. And I'm just going to write stretch / comp this time. Phase shift, how far left or right my graph is going. So that is my horizontal translation. D, your center line, is how far up and down. So that is my vertical translation. And what is that negative out front? That is your reflection if it's a negative A value. Okay. So, ready to try one of these graphs?
Ready as 11.
Good answer. Okay. Y equals 3 sine of x minus 4. So, if I walk you through this piece by piece, one important question I always start off asking myself, what graph is this? As in, yeah, is it sine or is it cosine? And I know it's a silly question, but once we get to mixing these around, you won't find it as silly. Now, in my brain, I'm currently visualizing what does a sine graph look like. And so my sine graph, if I'm just kind of making myself a little note, it's going to look like that, right? Starts at 0, 0, it's a mountain and then a valley. Okay, that's my mental here. That's what I'm kind of thinking through. When I go to draw it, that's what it's going to look like. Okay. Let's start identifying some information. Center line. Can you tell me what my center line is going to be? Agreed? Center line is -4, and he knew that because it's the D value, and the D is the value added or subtracted after everything else, right? Okay, so center line is -4. What that means is I'm going to label my x-axis as -4 instead of 0. Okay, now you can label it here at the end, or you can label it here in the middle, kind of like where 0, 0 would be. We can label it there. Your call, or both. Now, and it will go along with a little bit then my next question, which what is my amplitude? What was it?
3.
Okay. Amplitude is 3 because that is the A value multiplied out front. Yes, I'm just using that chart right up above. And that amplitude is how high and low does my graph go. So I'm going to write high/low. How high and low does my graph go? So an amplitude of 3 says my graph goes up 3 and down 3. Well, with that in mind, how should I label my y-axis? Okay. Except I don't want to specifically, yes, we want to go up 3, down 3. I don't want to specifically use -3 and 3, though. Because, no.
It would be -5, -6, -7.
This guy's -4. He's not 0.
Yeah.
Okay? You're counting the wrong way up, but yeah, great idea.
Down.
Okay. I was watching you count point up. And, yeah. No, that's an easy mistake to make. So the idea here is from -4, we're going to go 1, 2, 3 up. What is that going to be? So we're going to go to a height of -1 because I can count -3, -2, -1. Now, in all honesty, what I usually do, and actually I think I'm going to take them off, I usually do not have I usually just put, like I'll put tick marks, but I'll have the -4 and I'll have the -1. Okay, so like kind of what is my max? And then how low do we go? Okay, -5, -6, -7. Are we there?
Yep.
Okay, so instead of me having to take my graph and move it down 4, we're just going to stay on the x-axis. We've just relabeled it. Okay? Let's see. Center line, amplitude. We need to talk about the period. What about my period?
So it'd be 2 pi over b.
Uh-huh.
So 2 pi over 1, so 2 pi.
Yes. 2 pi divided by b. Where's b supposed to be? It's a number in front of x. So 2 pi divided by 1, which is 2 pi. So that is what one cycle is going to be.
Put cycle in the definition of period. It's math.
Okay, so that's going to be the length of one cycle of our graph. Now, let's see. We used our A value. We used our D value. Those were center line and amplitude. We've talked about our period. The other things we haven't talked about, A was positive, so no reflection. And then we didn't talk about a phase shift. But look at what does phase shift require? C over B. And what do you notice here? We don't have a C. If there's no C, C is then 0, and 0 divided by anything is 0. So there's no phase shift. My graph isn't going to shift left or right. So with that information in mind, I have everything I need to know. Labeling is going to be the hardest part of this job for some of you. Just saying. Some of you will have the hardest time drawing these things. We've labeled the x or the y-axis, right? Okay. Normally, my requirement is minimum you draw one cycle. Okay? One cycle in this case goes out to 2 pi. Now, when you label out to 2 pi, we're not just going to count 1 pi, 2 pi. Okay? We need to throw in some numbers other than just whole numbers. And so here's what I usually do, because if I think of the sine and cosine graphs as 4 pieces. So I always try and break it into fourths. So I'm going to have to go out as far as 2 pi, correct? And then I'm going to mark the middle point. What is the middle point of 2 pi? Pi. So I'm going to try and eyeball it, and I struggle with this on the BenQ, but approximately there is pi. And then I said I like to do fourths, right?
Yeah.
So what's in the middle of 0 and pi? 1/2 pi. which is pi over 2. And what's in the middle of 1 pi and 2 pi?
3 pi over 2.
Right? It's 1.5 pi if you want to think that way, but we all know 1.5 is 3 halves, so 3 pi over 2. Okay. Now, and guys, this is part of the reason I grade this stuff when it comes to the worksheets, because the labeling is so important. Okay. Now, we are ready to graph this. And as we graph this, sine. Sine starts where?
Origin.
Starts at the origin, okay? And so what I tend to do is I tend to go through and put little dots or marks before I just try and sketch the graph, okay? It starts at the origin, and then it has a max. It goes up, and it has a max a quarter of a way into your cycle, which in this case is going to be at pi over 2. Then halfway through the cycle, it crosses back through, and so my midpoint is going to be pi. And then 3/4 of the way through my cycle, it has a minimum. It has a valley. So that minimum is going to be below 3 pi over 2. And then at the end of the cycle, we're going to cross back through the x-axis. Now, how high and low did you put your mins and maxes? Did you line them up with, my max is lined up with -1 approximately, and my minimum is lined up at the -7 level approximately. That is important. That's something I'll look for when I grade. Now, it's connect the dots, or connect the dashes. Yes?
Are you looking for like perfection when it comes to that, or just like
No.
in the near area?
Well, what, are you talking about the highs and lows?
Like a wee little bit over.
Okay, a wee little bit over. If it looks like you gave me the effort to get it in the right spot, I'll take it. But when I go to grade these, there are times that we totally forget to check that, and people go way low or way high, and then I count off, if that makes sense.
Yeah.
Okay? If I can see effort that we tried, I mean, they're graphs. They're not going to be perfect by any means. But I'm looking for effort that we tried. Keep in mind, these are supposed to be curves. These are not peaks, as in points. Okay, they are supposed to be attempted curves. Okay, attempted.
I was going to say, mine.
Again,
It's attempted.
I'm not looking for perfection here. But, you know, there's a difference between a curve and a point. Like, that's not what this is supposed to be. Don't give me points, okay? Give me a curve here.
Okay.
So, okay, questions. That was a very basic example. Okay, ready to try 2? 2, we get a little more fancy. Okay, Connor stole the first question. What kind of graph is it?
Cosine.
Okay, now, so
Good job.
me personally, my brain says, okay, what's cosine look like? And that's a big old valley, right? So my brain, and this, I don't care what you guys do. Whoops. But that's kind of, my brain's just kind of visualizing a valley here. I don't really like how I drew my valley though, but
Kind of looks like a person.
I don't know. I'm not liking what I'm drawing here, but whatever. Okay. So that's what my brain is saying here. Okay. What else do we know? Okay. Center line, that D value add or subtract at the end is 1. If you want to go ahead and label 1, put it on there. What else do we know? Amplitude. What is the amplitude?
-2.
Disagree.
2.
The amplitude itself is 2, and the negative tells me that this is going to be a reflection. Okay, so the amplitude, remember, is going to tell me how high or low my graph goes. The negative out front is telling me that this is a reflection. And that, of course, is a reflection across the x-axis. So, a couple of things here. If we mark the amplitude off, count up and down for me. Hello. Yes, you can. Bye. Noah, you are needed in the guidance office. How is Mrs. Myers called, though?
I was just
Okay. What's up to put me at? What's down to put me at? I was counting my amplitude
Yeah, I put negative ones.
for the center line. Okay, so my center line was positive 1. Going up 2 is 2, 3. Going down 2 is 0, negative 1. And then we said there's a reflection. So what does this change?
Sorry, we just walked by. He was just trotting on by like he had not a care in the world.
And then about 30 seconds later.
I just saw
He's
Mr.
just running
Chris
behind
walking
him, and
by.
I was
So
like, oh.
he's in rare form today. Okay, now the reflection. What's that change? Instead of a valley,
It's gonna be a mountain.
my brain now has to visualize that, oh, we're going to draw a mountain instead. Or however you think about it. Okay, let's talk about what is the period of this graph. Two pi over b.
Yeah.
So in this case, it is 2 pi divided by 2, which is pi. So we now have a period of pi. So that period of pi is what one cycle is going to look like. Okay? It's going to look like one cycle. And phase shift. There's not a C, so no phase shift. Okay? We'll get to that on the backside. Don't worry. I won't let you down there. We'll get to phase shift. We've got to go incremental here, guys. Got to start basic, get you guys the basic idea. Now I'm going to add some more in. Like, there's a lot. Now, let's see. I need to label my x-axis. If we are just doing one cycle, which is all you're required to do in my book usually, we're just doing one cycle, we have to label as high as what?
Pi.
Pi, because we're going to take this 2 pi cycle and squish it into 1 pi. Now, with that in mind, you have options. You could take this whole curve and label out to pi. Or, if we want it to look a little more realistic, pi is usually what, about halfway? So I'm going to put pi kind of in the middle. I'm just not going to use my whole graph. If you want to use the whole thing, it's going to look just like, it's going to look stretched out, but it's all about how you label. And that's what I'm going to grade on. Now, okay, here's pi. I want to break this into 4 pieces, yes? What's the midpoint? So in between 0 and pi, I'm going to have a pi over 2. And then I ask that you mark the midpoint of each half, right? So now, minimum requirement, because it kind of depends, because when we squish this together, it gets a little harder to see. But minimum requirement, you've at least got to put the tick marks there, acknowledging that, okay, here's the middle of each piece. Now, it is important to realize how to count that. What's in the middle of 0 and pi over 2? Pi over 4, right? So this is pi over 4, pi over 2. What's the next middle? 3 pi over 4. And here's the thing, guys. Don't get hung up on the pies. You're just counting fractions. 1/4, 2/4, 3/4, 4/4. We're just counting fractions, right? With pi's thrown in. Because 2/4 obviously reduces to 1/2 or pi over 2. Okay. I think we're ready to graph it. Okay, cosine curve. Where does a cosine curve start?
Usually at 1, right? This one will start.
Okay, so normally a typical cosine curve would start at my high point, which is 3 on this particular graph. However, this is a reflected cosine curve, so we're going to start at -1. Okay, put a point there, put a mark there. I put something so I kind of have a way to connect my dots, so to speak. Except I tend to put little lines or marks. Now, think about, how do I want to think about this? Let's see. This is my beginning point, right? In the middle of the curve, if we start low, in the middle of the curve, we're going to have a mountain, right? So if I just go up here, and I don't know which way I should be teaching this, but the middle of my curve is pi over 2, yes? That's going to end up being my max. What do I do in the middle of those two? And we're specifically going to cross over where? At pi over 4. So you're starting low, 1/4 of the way in, we cross through. The middle of the graph, it would normally be a minimum, now it's going to be a maximum. And then where are we going to end our graph? We're going to end our graph at pi, and we're going to end low. And so what are we going to do in the middle? We're going to cross through 3 pi over 4. Now, I'm going to draw this. I'm going to try and give the correct curvature here. Notice on the end of the sine curve, I put arrows, didn't I?
Yeah.
It doesn't technically end there. And with the sine curve, it would keep going down and keep going up. Keep in mind with the cosine curve, these are minimums here. So I probably should have drawn that a little different. Is it going to keep going down from there? No, it's going to curve back up, right? So just kind of keep that in mind as you draw this. That as I draw this, something like that. Yes? And so I can put arrows on either end. Notice I do not have my arrows just going down, do I? Okay. Okay. Got the idea a little bit. And again, I'm not grading for artistry here. I'm grading for the attempt of, did you attempt to curve this back up? Did you attempt, is the shape there?
That's exactly what I just did.
Okay. We ready to try 3? I think we have time.
We'll make time.
Okay.
Yes.
Well, this one gets a little trickier, so. Okay, what do we know?
That's fine.
Sine.
Okay. This is a sine curve. My brain is visualizing a mountain and a valley. Okay. My brain is visualizing a mountain and a valley. Let's see. What about the center line? Nope.
0.
Center line is the number added or subtracted the end outside of the parentheses. It's that D value. And I don't have one, so it is 0. Amplitude. 1, because it is a coefficient in front of sine, but I don't have a coefficient in front of sine. So an invisible number there is a 1. Invisible number being added is a 0. So if I go ahead, did you guys go ahead and label this then? So if I label my center line as 0, my amplitude of 1 just means what? Up 1, down 1?
Yep.
Okay. Whether you use the whole vertical axis or part of it, I don't care. Just label. That's the thing. Your graph and your neighbor's graph can look totally different in size and stuff, but it's all about how you label them. Let's see. How long is one cycle going to be? Upside down. It's 2 pi divided by b, which is 3. Didn't you say 3 pi over 2?
Yeah.
Okay. So it's 2 pi divided by b being the coefficient of x. Hey guys, this right here is going to be a more challenging problem because we think of our graphs in fourths and everything, but now we're going to have to throw in thirds. Let's see. So this is going to be a cycle, right? Amplitude is how low and high we went. What else do I need to talk about? Phase shift. The hint is I wrote down the words phase shift for the first time, didn't I?
Yeah.
And there's a C value. And this is C over B. And my phase shift is going to be pi over 3. And that is a positive pi over 3 because your phase shift is going to be opposite the sign in the parentheses. Remember how horizontals are opposite the sign? That's what we're doing. So if you see a minus pi, it is positive pi over 3. If this had been a plus sign, we'd have a negative sign. So this positive pi over 3 is going to take my graph to the right pi over 3. You can also think of this, another way I teach this is take what's in parentheses, which is kind of like a 0, right? Take what's in parentheses and set it equal to 0 and solve. In other words, if you're forgetting about how to deal with the sign. So if 3x equals pi, and then x is pi over 3. So if you're struggling with remembering how do I do the signs, there's the proof of why it becomes positive pi over 3. Okay, did we get everything? Only thing we didn't talk about was a reflection, because there isn't one because there's no negative out front. Everything else we addressed, right?
Yep.
Okay, let's see. I labeled my center line. I labeled my amplitude. This time, now the good news is my period and phase shift both have thirds in them. But my period is 2 pi over 3. That means one cycle goes how far? 2 pi over 3. Don't worry about the phase shift yet. So here's what I'm going to suggest we do. Is label, which way do I want to do this? Okay, if we label 2 pi over 3, well, and here's what I'll tell you I end up doing often. If we're talking thirds, I end up taking a single pi and breaking it up. And I was trying to decide which way I want to do this one. So if I take this, and I label this as 2 pi over 3. We'll just go that way for right now. Okay? Now, what's the midpoint of 2 pi over 3? 1 pi over 3, yes? And I always say I want these graphs broken up into how many pieces? 4. Because they kind of lead themselves to fourths, don't they? So minimum requirement, put the tick marks there. Now, I'm curious though. What is in between 0 and pi over 3? What is a half of a third?
Pi over 6.
Pi over 6. Now, I would be perfectly fine if you just leave your labeling like this with the tick marks. However, if you're someone that you want to put them in there, think with me. This is pi over 6. This is 2 pi over 6, right? So this is 3 pi over 6, which is pi over 2. I'm kind of wondering, maybe I shouldn't have put these in because it gets confusing there. And then this is 4 pi over 6, right? As I said, really kind of wish I would have just left pi over 3 and 2 pi over 3. I would have been fine with that. Okay? Now, what's the catch before I draw this? We're going to have to do a phase shift pi over 3 right. Look at my farthest right point. What is pi over 3 to the right of 2 pi over 3? Because 2 pi over 3 plus 1 pi over 3 is 3 pi over 3, which is pi. Now, can you add an appropriate another pi over 3 in here? In other words, look. Here is pi over 3 length, yes. Here is pi over 3 length. So what do we need now? Another pi over 3 length. And random stray marks on the board from me. Yikes. Okay. So this would be pi. And again, minimum requirement, put a tick mark in there. I don't care if you label, when you get to the fourths. Okay. Let's draw. Your talent level will determine how you do this. Honest, okay? I teach this as I'm going to draw the initial curve, like in dotted lines, and then I'm going to shift it over. Okay? So my initial curve goes from 0 to 2 pi over 3, yes? So I'm going to draw a curve from here to here. Does that make sense? So if I'm drawing a curve from there to there, well, we're starting, what kind of curve was this? This was sine. So we're starting here at 0, right? We're going to max at above. No.
Pi over 6.
The first tick mark, which would be pi over 6. We're going to cut back through at the midpoint, which is pi over 3. I'm going to have a minimum at the next tick mark. I'm going to cross through at 2 pi over 3. Right? Because I'm just going there from 0 to 2 pi over 3. Now, I'm just doing dotted lines here. Because is that my final answer? No. So now, what am I going to do with each of those marks I just made? Move them over a pi over 3, which technically is 2 ticks if you want. Right? So like, instead of starting at 0, my graph, this cycle is now going to start at pi over 3. Instead of having a max here above that first tick mark, I'm now going to have a max at what I labeled as pi over 2, but it's in between pi over 3 and 2 pi over 3. Instead of cutting down through pi over 3, I'm going to cross down through 2 pi over 3. Instead of having a minimum below the pi over 2 tick mark, it's over here between 2 pi over 3 and pi. Instead of ending at 2 pi over 3, I'm now ending at pi. This one that I'm drawing with a solid line is representative of my final answer. Okay? That takes a little bit of practice there, doesn't it? Okay? So when we throw in those shifts, it gets a little crazier. Now, I'm going to go ahead and hand these out. Nothing else, so you have them, you can look at them. And here's what I will say. Technically, if you really want to, you can try this whole homework. I don't necessarily know if I'm going to do all of these examples and notes, but I think I will plan to do that. I feel like we need a little more practice on phase shifts before I could expect you to totally be able to do those on your own. So I will do a little bit more examples on Monday. But you might try the first 2 at least. Make some progress, because I think there's, 6 on here? So this whole plan on this to be due on Tuesday, okay?